All right, friends, we're now going to do a little bit of review with naming ions. So the first thing that I would suggest, if ever you're told to combine two elements together to make an ionic formula, is that you come up with the charge that they have to be in order to do that. So if I come over to the periodic table that I have here and kind of readjust it as best I can, we're going to pretend that the bottom doesn't really exist, even though they do. But in this instance, they always kind of behave in the same way. The first column has one valence electron, so those are always going to be your plus ones. And the second is always going to be the plus twos. We're going to skip over the transition metals. This group here in the middle, the ones in the pink, are the ones that we don't really focus on in terms of always having the same number of valence electrons. We will learn about them. They can behave as more than one thing. So we kind of skip over here. The 13 column is going to be plus 3. And then we go kind of the other way. These are the weird ones that are kind of the 4 group because they can either gain 4 or lose 4. So they don't really have a characteristic plus or minus. These guys have 5 valence electrons, so they like to gain 3. These guys have 6, so they need to gain 2. These have 7, so need to gain 1. And these guys over here, these are the inert gases. They don't like to do anything. So if you have that kind of down already on your periodic table, then you can come over here to the actual chart. Let me resize that where it needs to be. There we go. And you can assign those values and just kind of use that with the crisscross method that we learned about to fill in the table. So I'm going to go ahead and put some of those in. You should be able to look at your chart. Magnesium is in the second column, so it's plus 2. Potassium is in the first column. Calcium is in the second. And see, these are all of your positive. Ca, let me find where, it's in the same column as aluminum. S is going to be minus 2. I wonder if that's a typo, but maybe not. This is not an anion, so I'm going to have to cross that one out for now because we will get to those later. I think it was supposed to be SR, but we'll just pretend it's not there right now. Sodium is plus 1, and Be is in the second column, so it's going to be a plus 2. So those are all of your cations. They are the positive ones. They like to lose electrons. Going down this way, we have the anions. Those are the ones that are going to gain electrons. So for for chlorine, it's going to be 1. For oxygen, it's going to be 2. And for fluorine, it's going to be 1. And that's, again, based on the particular chart that we created over here. So now we just have to combine. So thinking about how we did this before, we have Mg, which is a plus 2, and a Cl, which is a minus. These do not cancel each other out. So that's where that crisscross method comes in. And I know it kind of messes with it, but we essentially need 2 chlorines to balance out the magnesium. So we write that as a little subscript. Whereas K is a plus 1 and Cl is a minus 1, which is totally fine. They do balance each other out. So the final formula there would be KCl. You just need 1 of each. So I'm just going to kind of go through and repeat that process. I'm going to need 2 chlorines to balance out the charge of the calcium. In this case, since aluminum is a plus 3 and chlorine is a minus 1, I actually need 3 chlorines to balance it out. And the same would be true for Ga because it is a plus 3 as well. And sodium and chloride, same thing. They're both plus and minus 1, so they balance each other out. You only need 1 of each. Be is a plus 2, so you would need 2 chlorines to balance it out. So this is roughly how you go through and write ionic formulas. MgO, because Mg was a +2, oxygen was a -2. Again, also notice that I'm always putting the cation first and the anion second. You always put the positive first and the negative second. In this case, I would have CaO. They are +2 and -2, just like magnesium, so that evens out. Aluminum, again, was a +3. O is a -2. So doing the crisscross method there, I end up with needing 2 aluminums and 3 oxygens. Keeping that same trend, I would need 2 GAs for 3 oxygens. In this instance, I need 2 NAs for 1 oxygen, and Be and oxygen balance out at +2 and -2. Fluorine, because it has the same charge as chlorine, actually behaves in the exact same way. So up above, you saw that we needed 2 chlorines to balance it out. Well, we would need 2 fluorines to balance out magnesium here. You could have KF, just continuing Ca. You would need 2 Fs to balance this out. You would need 3 Fs to balance out aluminum and gallium. And since Na is just a +1 and F is -1, you would need just 1 of each. And then Be, F, you would need 2 of them. So I hope that gives you a little bit of an idea if you're combining them together. Always the positive first, then the negative. And if you have different charges, you do the crisscross method to help you. Okay, so now we're going to get into the idea of naming compounds. I've given you an organic compound here. Now you actually have to go through and name it. So if we kind of remember how that went, you start with naming just the name of the element that comes first. So Na is, let me go ahead and turn on my pen here. Na stands for sodium. So I can write sodium. And then oxygen gets its ending name cut off. And in this case turns into oxide. So the correct way to say this in words would be sodium oxide. You're ending up changing out for that IDE ending. So then K2S would be potassium. And then instead of having sulfur, I cut off the FUR and I do sulfide. So it ends up being potassium sulfide. And notice it doesn't really matter what the subscript is. You could have 1 or 2 or 5. That part doesn't matter for ionic compounds. You're only looking at the specific elements that are putting them together. So we have magnesium, and then instead of chlorine, I'm going to take off that and make it chloride. So we have magnesium chloride. And then in the last one, we have calcium. Oop, that's a bad U. And then bromine turns into bromide. So your final compound would be calcium bromide. The tricky part is going the other way. And you can look at the names to help you, but then you're going to have to assign charges to go one step further. So for example, lithium ends up being element 3, and it has the symbol of Li. So that one is going to be Li. And bromine, or bromide, comes from bromine, which is element 35. And it has a negative charge. If I go to the periodic table, let me clear. Bromine is right here, so it has a -1 charge, and we were talking about lithium, which is over here, Number 3 has a +1 charge. So you need to have that information. Bromide comes from bromine. So lithium was a +1. And you need to know this when you're coming up with your final formula. In this case, the +1 and the -1 balance each other out. So I can just write my final formula as LiBr. But it's not always going to be that simple. Next in B, we have sodium, which by now I hope you've memorized is Na. It is in the first column, so it's a +1. And then we have iodide. So iodide comes from iodine, and it has the symbol of I, and it is -1. So again, the negative and positive balance each other out, and you just need one of each. Next up, we have cesium. And cesium, if we look at the periodic table, let's see if I can find it easily. Cesium is down here. It's element 55 in the first row. So cesium would be Cs +1, and then oxygen, which is a -2. So that means you have to do the crisscross method. There needs to be 2 cesiums for 1 oxygen. Again, so that the charges balance. Next up, we have beryllium. This is improperly spelled, so beryllium, there we go. Oxide. Oh, sorry, that kind of cleared it away. Beryllium is Be. It's in the second row, so it's going to be a +2. And then we have iodide, which is in the 7th column, or is a -1. Following that same crisscross method, I end up with Be to I, because I'm going to need 2 I's to balance out the charge on the +2 beryllium. Next up, we'll talk about transition elements in the next video.